We're the group that's going to be going to Brazil for the SAE Aero design competition. Myself, our job, this is Nestor and Andres, and our advisor is Mr. Dr. George Milikovic. Our team name that we came up with is Panther Air Cargo, to include the Panther and the aspect of us going in air. Our team objective is to compete in the competition in Brazil, which is going to be held in the end of October. What we have to do is we have to design, build an airplane from scratch to optimize it to the rules and the constraints that they've given us. Some of the rules include, let me talk about the different competitions that they have. One of them is the micro, the regular, and the advanced class. The micro is building very small planes. The irregular is building regular RC airplanes, and the advanced is building humongous airplanes. And we're going to compete in the regular. These are some of the requirements that we have: 61 meters to take off, 122 meters for landing. And this is the circuit that we have to follow. We can't do any acrobatic moves or, make any heart attacks to anyone. Our motivation is to be the first team from FIU to go and win the competition. There's going to be companies like Boeing and Airbus that are going to be over there to try and get some funding and represent FIU and the U.S. at an international level in Brazil, giving us a global aspect and leaving a legacy behind for future students. I'm going to hand it off to Nestor to talk about other problems that we have to do.
Thanks, Josh. Well, one of the biggest limitations that we have is a geometric limitation of 0.775 meters squared. We're going to try to, within the boundaries that they give us, try to design an aircraft that maximizes primarily the wing. This is our first concept. In this particular one, we had almost zero footprint created by the fuselage. The cargo bay was directly under the wing. We ended up scrapping this one because of the fact that it had a high frontal area in front of the propeller, which would, in theory, partially block the thrust. This was our second concept. In this particular design, we distributed the load along the entire length of the wing. We minimized the frontal area. We were able to use the airfoil we liked. However, it had a high displacement of the wings, and the bay is now supposed to fluctuate. And in order to do so, it became heavier and heavier as we tried to stiffen it. And, well, eventually we came to our current concept, which is more of a conventional design. It's got the cargo bay within the fuselage. We were able to use the airfoil that we like, and it's relatively lighter than the first two concepts that we tried. And we believe that this one will probably be relatively simple and not complex as far as making it work and work right for us. And now I'll turn it over to Andres.
One of the most important aspects when designing an airplane is the selection of the airfoil. Very important is the section of the wing. These are some of the concepts that we have explored. Since we want to lift as much load as possible, we want to get an airfoil that gives us the highest amount of lift. But we still want to not compromise the moment we're going to have in order to have a better stability, because we're going to carry the load. So these are some of the criteria that we use to select the airfoil. We're still doing research on what would be the best airfoil because, for example, in winter, when it comes to performance, the airfoils that have the thin trailing edge on the better. But when it comes to manufacturability, the trailing edge here, it becomes a challenge for us. Some of the software that we have already used and we will use to optimize the size, the geometry and the size of the airplane. This is the timeline we've been trying to follow very strictly. We are planning to starting to build June in the summer, maybe in the middle of the summer. So we already have done some calculation analysis on design concepts as well. We already went through that. We're planning to film a video of the flight at the end. We want to give credit to our pilot. This is Keisha Pope. He's a very experienced pilot, RC pilot with several years of experience. So he's going to be part of the team.
Question? This is your, yes.
Protected by the
What kind of materials are you proposing to use for the aircraft?
For the wing, we're gonna use, we're thinking of using polymer, to manufacture the wing, because it's light, it's persistent. I don't know, we're thinking of using extruded polypropylene.
That's for the skin.
That's for the wing,
The skin of the wing, but what about the structural part of the wing?
Yeah. The wing is going to be, a solid block of polymer. We're going to reinforce that with hopefully carbon fiber rods, maybe going across the wingspan. Maybe some ribs as well. We're thinking of using ribs.
Yeah, actually, Professor, the way one of the ways we're thinking about doing it is using a hot wire method to cut out the foam, but we're going to have possibly 3 sections. The trailing edge being so thin, we might end up using balsa ribs, covering them with the typical light aircraft skin. Within those 2 or 3 sections, we'll have longerons that'll be made out of birch plywood, which is the typical for that type of use for RC airplane use, and it glues well to the styrofoam. There's no, it's not like an acetone base or anything like that where it's going to melt. By the way, we also planned on, as far as the styrofoam, I'm calling it styrofoam. I know it's got a more technical name for it. You can use basically a watered down version of Elmer School glue. You brush it on there, and you can use some paper, and you put it on there, and you brush it on there again, and it forms a very hard skin. And it's basically biodegradable also, but without using harsh chemicals.
Okay, well, based on the purpose of the aircraft, I've quantified the lift drag. And how do you propose to confirm that the airplane will do whatever you want it to do based on those lift drag quantifications?
First of all, we're gonna select the airfoil, ideal airfoil to get as much lift and of course some stability with the momentum. But we're planning on going to Aero to test it, to see if the actual values of lift and the drag that we get from the within the test tunnel are consistent with the simulations that we're going to eventually run at the beginning of the summer.
So you're going to do some CFD, you're going to do some wind tunnel?
Before the wind tunnel test.
All right.
I'm up. Okay. So, just in my opinion on this type of stuff, the most important thing is aero stability. What I mean by aero stability is, of course, the aero controls aspect, right? So if you go back to your design itself, so the next one, yes, right. So have you guys done the analysis for, say, aerodynamic center and center of gravity to make sure that you have the positions correct for your wing and airfoil, and then you fail to swim?
Well, sir, let me address that. First of all, it's not an accurate depiction.
Of course,
okay? Because and I know you're an aerospace engineer, so let's talk about it. The horizontal tail should be, the surface area should be approximately 15%.
Right.
Versus the wing, and that's far smaller. So this was just a concept thrown up there to depict the idea of it. Oh, yeah. Well, okay. But within this particular concept, the airfoil, the only thing we haven't decided yet is the airfoil. Once we decide the airfoil, as you know, the center of lift should be at 25% more or less of Mach. The center of gravity should be slightly forward for conventional design, and that's the design we're going for. So I'm guessing, we haven't done the actual weight balance yet because we don't have the airfoil. If we go for this other custom FIU designed airfoil, which I have some concerns about, that's one of my concerns, is exactly how is it going to affect the center of gravity.
So here's my suggestion, just from my aspect. Your airfoil is not going to be the whole time. It's not. You guys are flying one specific pattern. You're just making a circle and coming back down. Just pick one. To be honest with you, just pick one. Because pick one for ease of manufacturing. You'll get enough lift to get a 3-pound plane up in the air.
Well, it's-
Or
Or
how
the
much
cargo,
ever it is, whatever.
the cargo itself, is we have a 20 kilogram restriction on the cargo that we have to lift, and what they're gonna judge us on is the weight of the plane and the weight of the plane with the cargo.
So what I would say to you is this: if you go to any of these competitions, what happens every time is majority of the planes crash and burn, right? And the reason they do that is because people get a little too complex with their analysis, and it becomes very, very hard to have a stable aircraft, right? If you have a stable aircraft, you can load it up with all the weight you want. As long as you understand that distribution, you can do whatever you want.
Well,
to
the
do,
other reason
right?
we can go with something more fancy is because our pilot, he's very,
Pilots
He's
can only fly
experienced.
planes that are stable, right?
Well,
I
yeah.
understand that, but his thumbs aren't fast enough to do, to do that.
Right.
So I would say pick it and start going.
Start building, okay.
The other thing I would say is just in typical aircraft, right? The most important thing is to kind of have smooth transitions between.
Yes, sir.
Right,
Yeah.
so just, when you see this here, I see a lot of sharp edges.
Oh, no, yes, sir. You're right.
So just
Of
keep an
course.
eye on that. Yeah.
Yes, sir, that we
Yeah.
fully intended to do.
Right. Just one other quick, in general thing, just be careful with the word optimize, because optimize doesn't mean try 3 different things and then pick the best. There's very specific reasons. You guys are working with the right guy with optimization, right? But just be careful that if you say you're gonna optimize it, that you're using some algorithm to reach a local minimum, right, or something like
Right.
that. So, that's all. But yeah, good luck. So
Thanks,
you're
sir.
in October, so you
Yes.
should see the competition, right?
Right.
We sure hope so.
we're on the waiting list to registration. So.
Okay, great. Okay.
Any other questions?
No.
All right.